joined Ms. Anne-Marie Cunningham at Science Friday Initiative. And my presentation is entitled Communicating Science Through the Web, Salt Marshes and Sickle Cell. Okay, so don't mind the black square. It was supposed to be a video, but unfortunately it can't play. Okay, so science communication, basically in Science Friday Initiative, that's the topic we were working on. So science communication is basically talking about science through the media to inform people about the latest science topics. So Science Friday Initiative is a nonprofit organization founded by Science Friday's Ira Flato, and its mission is to provide a public platform for understanding and discussing the news in science, and it is achieved by Science Friday and Talking Science. So what is Science Friday? Science Friday is a weekly science talk show which airs on National Public Radio, which is known as NPR, every Friday from 2 p.m. to 4 p.m. And it's hosted by Ira Flato himself. And Talking Science, where I was working at this summer, is a program created to inspire and educate young people about science through the web. So students basically blog about science topics through writing, video, or photography in the website. And there's a website right there, and feel free to go visit the website whenever you have time. Okay, the great thing about working at Science Friday Initiative is that we get the opportunity to blog about whatever interests us. So what interests me is salt marshes. And a salt marsh, if you guys didn't know, is a low-lying wetland that is frequently flooded with salt water. So the latest news in salt marshes is the oil spill in the Gulf of Mexico, as you all heard of. And due to the oil spill, it has threatened coastal marshes in about 5 states. And why would salt marshes interest me? Well, they are one of the most productive ecosystems in this world. And even before the oil spill, they were endangered due to its references as a wasteland. And today, some marshes are now nature reserves and can be visited. The pictures here on top is Piermont Marsh, and below is Rye Marshlands Conservancies, and those two marshes are two marshes that I was able to visit. So Piermont Marsh. It's one of 4 tidal marshes in the Hudson River National Estuarine Research Reserve System. It's influenced by the tidal creek and is exposed to seawater from the Atlantic Ocean, which comes from the Hudson River, and fresh water that flows down from the Adirondack Mountains. Piermont is an estuarine habitat. An estuary is a partly enclosed body of water located at the coast. Its water supply comes from multiple rivers or streams, and it connects to the open ocean. Okay, right here is a picture at the top, a satellite picture taken of Piermont Marsh. And below is students from the Yeoman's Leadership School of East Harlem who had the opportunity to research our Piermont Marsh, including me. So, One Woman versus a Salt Marsh is the title of my blog, which will fortunately be posted in a couple of days on talkingscience.org. And it recalls my experiences along with my teammates researching in Piermont Marsh. And we were studying water quality and the effect of ocean dynamics on hydrological exchange in the marsh river system is the title of our research. So throughout the research, data based on various physical water parameters have been collected from the Hudson River, the tidal creek, and the interior pools on the marsh surface. And what we wanted to observe in the marsh is that even though we know the presence of saltwater and freshwater in Piermont Marsh, we want we don't really understand how it gets onto the marsh surface and into the interior pools. So methods and materials, 2 multi-probe sondes, which are basically these tall metal-looking tubes containing sensors that scan water quality, were used to monitor physical water parameters, and those physical water parameters I speak of are such as salinity, pH, dissolved oxygen, temperature, depth. And the sondes were deployed in the 3 locations of study. And the sondes were serviced monthly, and this includes downloading the recent data files and replacing the batteries if needed. And in order to approach the sondes, canoes were used to navigate the marsh, and the monthly visits require patience and a strong deal effort. When I say patience, it refers to the time it takes to download the recent data files, and in order to retrieve data from the sondes, we will have to get out our canoes and walk on the marsh surface, which is really hard due to the numerous mud holes that we try to avoid, and it's very muddy there. So these are results along with some pictures. So relationships documented between both locations based on salinity levels prove that the Hudson River feeds the tidal creek. When comparing the Hudson River and the tidal creek to the interior pool, negative relationships are often shown. The interior pool is salty, and therefore water from the river is getting into the pool, but its path is still unknown. Water from the Hudson River does not enter the pool directly. The pool only gets water from the river when the tidal creek is high enough to reach the marsh surface to overflow the surface. So as of right now, 2 of my former teammates are continuing research at Green Rock Marsh, and I plan to follow along with the research as soon as school starts. And here's a slide of the Rye Marshlands Conservancy. And thanks to my mentor, Ms. Anne-Marie Cunningham, along with her and several of interns of Talking Science, we were able to visit Rye, New York. And Addison Beal, the curator of Marshlands Conservancy, gave us a tour around the local marsh in Rye, New York, and gave us a little facts that I will go through really briefly. The marsh in Rye contains a large amount of Spartina alterniflora, which is a salt grass. And species, just to name a few species that settled in the marsh, include silversides, which are fish. Birds also settle there, such as clapper rails. Another type of salt grass that you find at the Rye Marsh is the Cyclis spicata. And we were able to caught view of some fiddler crabs, which there's a picture all the way up in the right corner, but you can't see them because of their miniature size. And also in Rye, New York is a Burnham homestead, and it's a historical landmark. And it's a historical landmark because the property has been in the Bird family since 1852. And among the family members of the Bird family, 3 men are, there are 3 men that come to mind. And those 3 men are Henry Bird, Roland Bird, and Julius Bird. So Henry Bird is the father of Roland and Julius Bird and was an entomologist. Roland Bird was a pioneering paleontologist, and he's known for discovering 120-million-year-old dinosaur bones and footprints down south of the U.S. I believe it was Texas. I don't recall well. And Julius Bird was a curator of South American archaeology at the American Museum of Natural History, and he's known for unveiling a hidden ancient civilization down in South Africa, and is also known as a possible inspiration for Indiana Jones. So up in the right corner is Julius Bird. kind of looks like Indiana Jones, and at the bottom it's, I believe, a 1917 picture of the Bird homestead with Henry Bird in front of it. So sickle cell comes to my attention because I really want to know a lot more about it as a carrier of sickle cell trait myself. So all of you must be familiar with sickle cell already because a couple of weeks ago we had a guest, Dr. Robin Brielle, who made a presentation about sickle cell as well. So just gonna go through it. And sickle cell is an abnormal red blood cell that has a crescent shape and an abnormal form of hemoglobin. And right there you can see the comparison. There's a normal red blood cell, which is like a little disc shape, and right there is the sickle cell, which is like a little C. So it consists of many branches such as sickle cell anemia, sickle cell disease, sickle cell trait, which is what I have, and contains abnormal hemoglobin that causes the red blood cells to have a sickle shape instead of its normal disc-like shape. The sickle cells don't move easily through blood vessels, and this causes the cells to clump up together and block blood flow. And it is a genetic disease. You can't get it from anyone else unless it's inherited to you. So sickle cell disease, the blocked blood vessels cause sickle cell crisis. The sickle cell crisis refers to the sudden pains throughout the body caused by sickle cell, and crises can vary from acute, which are sudden and mild, to very severe, to chronic, and these chronic pains can last from weeks to months. And there's no cure, unfortunately, but once going through crises, patients are treated with medicine such as hydroxyurea, and because of the latest medical technology, people with sickle cell disease are able to live as long as 50 or even longer than that. Before, when it was first discovered, people could only live for like, I don't know, 9 years old. And sickle cell traits, thankfully, it's not effective. It's just one gene which could be passed on to the other generation, and the carrier of the trait is capable of living a normal life. So the disease is prevalent among malaria-stricken areas, such as Africa, the Middle East, the Mediterranean, and even the Caribbean. And what's interesting is that those with sickle cells somehow have a greater chance at surviving from malaria than those with normal blood cells. Because once parasites enter the blood vessels, they, since sickle cells don't live long, the parasites also die off because they don't have any normal blood cells to be able to live in the body enough to affect the carrier. So these are my references. My acknowledgements: Ms. Amory Cunningham, Danielle Dana, my co-workers at Science Fair Initiative, the Piermont Marsh team, Lamont Doherty, Irving Survey, Dr. Roberta Moran, apologize for that typo, Dr. Robin Brielle, Marshes and Sickle at Rye, New York, my supportive family, Dr. Stepha Acharya, the Armature Society staff, and you for listening.